In this video, I'm going to illustrate how you would connect the outputs from Triggy into the digital inputs or trigger input of an EEG system. In this example, we'll use the Biosemi ActiveTwo system. So you'll see here that we have a Biosemi USB interface. This is the AD box, so the data come out of the AD box via fiber optic cable into the optical receiver along with the clock. The clock drives the sampling of the trigger port, which is on the back of this device here. And what we're going to do is connect that trigger port to the 16-bit TTL output from Triggy. So first, let's just set the stage. So let's look at what kind of stimulus we have. Here on the Audacity software, I've created a click, and if I zoom in on that click, just by grabbing this and pulling it over, you'll see that the click has a short duration negative going set of data points here, and then everything else is zero. And this quiet period will give us enough time to be able to easily follow on the screen what's happening. So if I play it once, you'll hear the sound, and that sound will then be routed through this audio interface to the input number one of Triggy, and we're going to connect our EEG trigger port to the Triggy TTL output port. If instead of the old style Biosemi USB interface or optical receiver, you have the newer style, which is labeled Biosemi on the top. It's kind of a maroon color. It has a display with some status information on the front. It has the trigger port on the back along with USB and optical input. If you're using the newer style, then one main difference between how you connect the two is that the new style box can't plug in here directly because it has other connectors that will obstruct the connection. So actually what you need to do is use an adapter cable in between. I have a relatively long one here. You could use a shorter one. Let's just take this example of a longer adapter cable. It's basically just a straight through 37 to 37 cable. And I'm going to connect it to the TTL output port, and on the other side I'll connect the USB cable, and then I'll replace this STST cable with an STSC cable. So the difference is just that this one works with the newer style receiver. It has a square connector on the receiver end. Plug that in here. And we should see then an indication on the front panel of the receiver that the clock is being received along with data from the EEG device. And then when I send a trigger bit or an event to Triggy, that sound is acknowledged by Triggy, but it's also seen here as a trigger bit on the front panel of the Biosemi interface. And in the EEG software, if I start this, you'll see that with each click there's a colored line that appears. So that colored line indicates that one bit is being raised momentarily. And I'm going to go in the EEG software and change the screen length for the moment, just so that it's a little easier to see multiple repetitions of this sound. And let's just start it again. And I'll go over here and use the automatic repeat. So on the EEG software, you'll see these individual instances of the sound represented as TTL raised bits on pin number 9. If I switch this trigger format to decimal, you'll see that that is represented here as a 1 followed by 0. That's just in the context of triggers 9 through 16. So in fact, in your data file, that is the middle byte of a 24-bit channel. So in ActiveTwo, you have to do a little bit of masking of bytes in order to be able to interpret that as a 1 followed by a 0. Okay, so next step is to answer the question, how does the trigger generated by Triggy relate to the sound recorded on its input? So we've gone over that in the basic sound demonstration video. And you can see in that video that the timing of Triggy partly depends upon the quality of the audio interface. In this example, I'm using a high quality audio interface that generates good quality sound. It's not necessarily one of the preferred sound devices for a presentation because it has a USB interface, so there may be some reasons why it isn't going to behave as predictably with respect to other parts of the computer. At least within the context of all the sound channels, it's very accurate and its quality of sound output is very high. So let's look at how those sound channels relate to trigger outputs from the trigger port. So in this case, I have the Biosemi USB virtual serial port connected to the back of Triggy. So those signals pass through Triggy and into the ActiveTwo trigger input port, and they'll be related or they'll be displayed on Trig 1 through 8, this section in the EEG software. In order to modulate those bits, I'm going to use the presentation software. So I'll just open up presentation. And I have a click somewhat shorter than the one I was presenting in this example through Audacity, but it's a short click and about a 500 millisecond delay between them. And this is set up in the presentation software. So with each presentation of the click, we're also sending a port output code. And that port output code will go out the virtual serial port, and we'll be able to compare the timing of those two. In order to compare the timing, we'll use the oscilloscope software known as Tracer DAC. Okay, so I'm going to put the Tracer DAC up on this screen. And for the moment, I'll just have these two channels. So I have channels 0 and 1, and in my DAC hardware settings, you'll see that 0 is the DAC number 0 is first, and then DAC number 2 is second. And I'm going to ignore the rest. But so DAC number 0 and 2, those are even, so they're representing digital channels from Triggy. So the way I have them assigned to Triggy is that the DAC 0, displayed on the oscilloscope as channel 0, is coming from the first Triggy channel, and the digital representation of the trigger, which is coming from the serial port, is represented on channel 1 of the oscilloscope software. And so let's just play this experiment and see what that looks like on the screen. Here we go. So right away you can see that the triggers that are coming from the serial port are somewhat delayed and jittered with respect to the triggers coming from Triggy. So Triggy is generating this red trigger output on channel 0, and it's the trigger channel by virtue of this T being in a full red square. So that's where my trigger marker is set at 0 of that channel's signal exceeding this threshold. And the other channel, channel 1, is jumping around in time relative to the trigger channel. Let's just play it again. So part of this is because the sound device that I'm using, this Focusrite, is interfaced to presentation over USB. There's some buffering that's happening in order to get data to the sound device. But also the trigger device that I'm using is a USB mediated trigger cable. It's pretty accurate, the Biosemi trigger cable. But here we're looking at jitter and delays. You might have been paying closer attention than me, but somewhere in the range of a millisecond, maybe more than that. In some cases, the triggers from the serial port were preceding the sound. The reason for that is just a little nuance in the presentation software. I've put in a little fudge factor in order to try to bring the triggers closer in time to the actual sound appearance. There's a delay of about 10 milliseconds in the sound appearing. So I've set some settings in order to try to optimize its sounding, but the best I can do is this jitter in that range of about a millisecond to maybe 2 milliseconds on the serial port trigger. Now, Triggy itself is quite accurate, and let's just look at how accurate that is by enabling this third channel. And this third channel will show us the actual sound that's coming in, the analog sound that's coming in, and you'll be able to see the red code with respect to the sound. And the orange signal is obviously jumping around. That's the one that's coming from the Biosemi USB serial trigger cable. That jitter might be a little less if we were using a sound card that was optimized for presentation, like one of the Sound Blaster devices that they recommend. But what you see here is probably typical of most sound devices that are not specifically recommended for presentation. You might be able to get a little bit better delay and jitter specs than that for the optimized sound cards, but this is pretty typical. So you can see that there's a big advantage in triggering directly on the audio from the sound device, and that's what this red code is. So let's just look at what those codes look like in the EEG software when we're actually recording. So the two codes that are aligned, the one that's at the top of that trig 1 through 8 field, and the code that is well below it, in yellow, those two relate to the USB serial port. So the code comes in here on the back of Triggy, on the Biosemi trigger cable, and it is detected by Triggy, and Triggy also generates an output bit. So the top code that you're seeing, the short top code, is actually the serial port trigger event, and the yellow one is basically a reflection of that. Triggy acknowledges that it received it with a code of the same duration on another bit down below. So everything on the 9 through 16 is Triggy's representation of events that it has detected, and so the yellow one is saying, I've acknowledged the bit that's being set above. The one in the middle, the longer code, is actually the trigger output code that's being generated by Triggy for the sound coming in. So you have these 3 bits. You'll need to pay attention to the ones that are important to you, of course. If you weren't using the serial port, you would have just the one long pin raised in the middle. And let's try changing the format to decimal so that you can interpret those codes as numbers, as we had seen it before. So on the top you see 1 and a 0 below it. On the bottom you see a couple of codes. There's 9 followed by a 1 and then a 0. So there are a couple of things happening there at once, as you recall, the 2 short codes and the 1 long code. So in fact, there's a little bit of time offset between the beginning of the long code because the serial port code, which is the high one and the bottom one, they're not happening in a precise, consistent way with respect to the longer code. That may be a little bit hard to follow, but it's much easier to see when you look at it in the analog format. You can see that the bits are being raised in a different order. What I would recommend when you're using Triggy is instead of using the serial port trigger cable, you tell your experimental control software just to play the sound, and then you'll be seeing here on the trigger section for the recording software, just seeing that 1 bit, and that's the bit that's being raised by the receipt of the sound from the audio device. Then your codes are perfectly aligned with the sound, and there isn't any way to do that any more precisely than this is doing. Except potentially to raise the sample rate. Right now I have the sample rate relatively low for this device, but we can go to a much higher sampling rate, and that might increase the precision somewhat.